He said we want to look at the concept behind rate of flow of discharge. Now, what do you understand by the word rate of flow? Is either you say rate of flow or you say discharge, right? Now, keyword flow, meaning the rate at which you have your liquid flowing. What we are just doing here, earlier we made mention that we have different type of flow. We said we have steady flow, we have laminar flow, we have turbulent flow, we have steady and unsteady flow, we have uniform flow, non-uniform flow, a lot of flow, right? Now, we want to see when this flow is inside a pipe. When you have this flow in a pipe, we want to see the behavior. Your flow can be compressible flow or incompressible flow, right? Rate of flow or discharge is defined as the quantity of a liquid flowing per second through a section of a pipe or a channel. Rate of flow or discharge is defined as the quantity of liquid flowing per second through a section of a pipe or channel. It is generally denoted as Q. Meaning that your rate of flow is denoted as Q and the unit is in meter cube per seconds or liters. This is the unit of rate of flow. It's a rate of flow, or you call it discharge. By definition, what do you say? We said rate of flow is the what? Is defined as the quantity of liquid flowing per second through a section of a pipe. Now, or a channel, meaning pipe or channel. Let's do a practical illustration to that. Let's say you have your pipe. Let's say you have this pipe, and you have fluid flowing. This fluid is flowing with respect to time. Now, we want to determine the quantity of this fluid with respect to a particular time. Let's say the time, this fluid is flowing with respect to 5 seconds. For 5 seconds and 10 seconds, the quantity will be different, right? By rate of flow or discharge, meaning this Q. By this Q, you'll be able to determine it. And the formula for this Q is Q, which is the discharge, is equals to the area times velocity. Q is equals to what? Area times velocity. What's the unit for area? Meter square. What's the unit for velocity? Meter per seconds. Therefore, Q has its unit to be what? Meter cube per seconds. And this is it. Are you getting me? But there is a law governing discharge or rate of flow. This law is called continuity equation. By definition, what is continuity equation? By continuity equation is based on conservation of mass. It is based on conservation of mass. It states as follows: if no fluid is added or removed from the pipe in any length, the mass passing across different sections shall be the same. If no fluid is added or removed from the pipe in any length, the mass passing across different sections shall be the same. The mass passing across different sections shall be the same or will be the same. Now, what this means is that from that continuity equation, in other words, what this is saying is that The rate of flow entering a section is the same as the rate of flow leaving that section. I get what I'm saying? But that definition, based on conservation of mass, it is referencing to mass in each section. From continuity equation, is stated as follows: if no fluid is added or removed in any length of the pipe, the mass passing across different sections shall be the same, shall remain the same. Now, I'm not saying that. In other words, what this means is that the rate of flow entering a section is equal to the rate of flow leaving that section. But this law is reference. It is explaining continuity equation based on mass. You get what I'm saying? It is explaining it based on what? Mass. Now, let's do a proper illustration. Since from that definition we are referencing to what? Section. The idea of sectioning is that you have section 1, you have section 2, you have section 3. When you go advanced, you will see, particularly for civil engineering students, you will be sectioning a lot. The idea of sectioning is that you are separating something, right? You are splitting. Now, meaning, let's consider this pipe. Let's say you have this pipe. Now, from here, this is the inlet. This is the inlet. This is the inlet. This is the what? Outlet. Let's call the inlet section 1. Let's call the inlet section 1. Let's call the outlet section 2. What's entering this section 1? Flow, rate of flow. Meaning liquid. Liquid is entering this section 1. Right? The idea is that we want to determine the quantity of the liquid entering this pipe. This is a pipe. This is a pipe. It's a pipe or channel, right? The idea of rate of flow is that we want to determine the quantity of the liquid entering this pipe. From section 1, your liquid is entering. From section 2, your liquid is leaving. Are you getting me? Meaning, for section 1, you have Q1. For section 2, you have Q2. What this means is that you can relate the general formula of discharge, which says that your discharge Q is equal to area times what? Velocity. What that means is that for inlet, for Q1, it has area, it has velocity. For Q2, it has what? Area, it has velocity. Meaning, this is what? Q1 is equal to A1, V1, and meaning for the inlet, which is Q1, you have what? A1, V1. Section 2, you have what? A2, V2. This is continuity equation based on the flow. But based on masses now, meaning the mass remain constant. Now, this is it. Let's say you have this from here. Your continuity equation is saying that Q1 is equals to Q2. That is A1, V1 is equals to A2, V2. A2, V2. Right? We will come back to this. We will see the condition that we are going to have our continuity equation like this. The condition whereby we have our continuity equation in this form. Let's call this equation 1. Now, following conservation of mass. By conservation of mass, it says that across any section, your mass remain what? The same. Now, let's say you have this pipe. Let's say you have this pipe. Let's say you have this pipe. Let's say this is section 1, this is section 2, and this is section 3. For section 1, this is a junction, right? For section 1, the flow entering it is what? Q1. By the time Q1 gets to this junction, it's going to split, right? Meaning you have Q2 and what? Q3. By continuity equation, it means that Q1 is equal to what? Q2 plus Q3. Have it in mind that Q1 is going to have area. Let's denote the area as A1. It's going to have velocity. Let's denote it as what? V1. is also going to have density. Let's denote it as what? Rho 1 is also going to have mass. Let's denote it as what? M1. Similarly for section 2 and section 3. So this becomes A2, V2, rho 2, and M2. This becomes what? A3, V3, rho 3, and M3. Now go back to continuity equation based on conservation of mass. Mind you, this one has the distance. You know, this guy has distance. Let's say this is the distance. This one too has distance. Let's say this one too has it distance. The distance here, let's say this is D1. Let's say this is D2, and let's say this is D3. Now go back to continuity equation in terms of conservation of mass. Read what you have. If no fluid is added or removed from the pipe in any length, the mass passing across different sections shall be the same. What this means is that M, which is the mass, is equals to M1, is equals to M2, is equals to what? M3. What this means is that this inlet, that's what will determine the flow, the quantity of flow in section 2 and section 3. By the time you sum this up, you have the actual flow entering it. I get what I'm saying? By the time you sum these two up, you have the actual flow entering this pipe. Now, what this means is that, you know, for section 2 now, if you add flow, if you add fluid or you move fluid, the mass will change. I get what I'm saying? For section 3, if you add fluid or you remove fluid from what you have there, the mass will also change. Similarly, if you remove fluid or you add fluid to this section 1, the mass will change. So by this guy, what he's saying is that the mass remains constant if only and if no fluid is added or removed to what the initial flow is. I get what I'm saying? I get what I'm saying? Yeah. Meaning you have continuity equation based on conservation of mass. Now, the flow. If the flow might be a compressible flow or incompressible flow. If it is compressible flow, you have your continuity equation. If it is incompressible flow, you have your continuity equation. Now take note. For compressible flow, density is constant. For compressible flow, density is constant. Density is constant. Whereas for incompressible flow, density is not constant. Meaning for compressible flow, density is constant. Whereas incompressible flow, density is not constant. Now, let's see this. From continuity equation, he said Q1 is equals to what? Q2, right? Meaning rho 1, area 1, V1 is equals to what? Rho 2, A2, V2. But in case of compressible, we said density is what? Constant. Meaning density 1 is equals to what? Density 2. Meaning from here, call this equation 1. Since we said call this equation 2. Since we said from equation 1, rho 1 is equals to rho 2. You can relate this mathematically by saying that rho 1 cancel rho 2. True or false? They are the same. Then this equation 1 becomes what? A1 V1 is equals to A2 V2. Call this equation 3. Now compare equation 3 and equation 4. What this is telling you, the fluid in this pipe, is it a compressible fluid or incompressible fluid? We said for compressible fluid, check what you have in your notes. The density is constant. Meaning from this equation 1, continuity equation, the inlet is equals to the outlet. Meaning it is compressible flow. Meaning rho 1, area 1, velocity 1 is equals to rho 2, area 2, velocity 2. But we said density is constant, meaning they are having the same value. Then mathematically, what this means is that density 1 cancels density 2 because they are the same. Now equation 1, you can write it as what? Equation 3. Right? Then what we've done before, you can now deduce that this equation 4 What type of flow, what type of liquid is inside this pipe? Is it a compressible liquid or incompressible liquid? Compressible liquid. It is compressible liquid. So meaning generally for compressible liquid, this becomes your what? Continuity equation. This becomes your what? Continuity equation. For incompressible liquid, you have your continuity equation to be what? Rho 1, right? Area 1, velocity 1 is equals to rho 2, area 2, velocity 2. So that's what we are saying. That's what it means. You know, mind you, the other parameters, you know, from this place, I have diameter, I have mass, I have other parameter, meaning same idea. Meaning the first, the section, the parameter of the first section is equal to the parameter of the second section. That's what it means. Do you understand what I'm saying? Now, this continuity equation, we have it in different form. We have it in Cartesian form, continuity equation in Cartesian form. We also have it in polar form. But whatever thing that we are learning here, that's what we are going to apply to the Cartesian form and to the what? Polar form. And the overall idea is that you want to determine the quantity of flow in a pipe. You want to determine the what? Quantity of flow in a pipe. You understand what I'm saying? Now, let's take down this example. Example 1.